We're going to talk about graphing sine and cosine functions when there's a phase shift. And to do that, we're looking at questions 27 and 28 from last night's assignment. This is assignment 16. And before we get started on these questions, we're just going to refresh our memory about, standard form for sine and cosine. So for sine, it's y equals a sine of bx minus c plus d. And cosine looks exactly the same way, but instead of sine, it's cosine. So y equals a cosine bx minus c plus d. Now, the first thing we do for any of these functions is we identify a, b, c, and d. Thus far, our c values have always been 0. That is different for 27 and 28. So for number 27, the sine function, a is 1 because there's no multiplier in front of the sine. B is 1 because there's no multiplier in front of x. C, and remember that this negative sign is part of the equation. So for us, c is equal to pi, right? Remember that x minus pi means a shift to the right pi units, and that means c is positive pi. And then in this equation, d is 0. And so using a, b, c, and d, we can talk about the amplitude, the period, the phase shift, and our vertical shift. So amplitude is informed by a. Here a is 1, so amplitude is the absolute value of 1, which is just 1, and that's, the same amplitude for our parent function. Period is 2 pi over b, and for us, b is 1, so our period is just 2 pi over 1, which is 2 pi. And that's, again, the same period as our parent function. Then we talk about phase shift. And our phase shift, remember, is c over b. And so for us, that is pi over 1, which is pi. And what that means is we're going to move right pi units. All right, and the last one is vertical shift. And because our d value is 0, our vertical shift is 0, or there is none. So the only thing that has changed about the sine graph from the parent function is that it has moved right pi units. So what we're going to do is we're going to draw our axes. Because the amplitude is 1, I just need a positive 1 and a negative 1 on my y. And we are dividing the x-axis in denominations of pi. So there we go. Now if we think about the original sine function, what does sine usually look like? Sine usually goes through the origin and comes up to 1, around pi over 2, goes back down through pi, hits negative 1 around 3 pi over 2, and comes back up and hits the x-axis again at 2 pi, right? And this is a continuous function, so we have arrows on the end. Now that is the parent function there in purple. This function has been moved to the right pi units. And so when we graph it, we take these key points, our starting point, our x-intercept at pi and our x-intercept at 2 pi, and we move them to the right pi units. So I am going to first move my 2 pi point, and I'm going to move it to the right pi units, which puts it at 3 pi. I'm going to next move my pi point and move it to the right pi units, which puts it at 2 pi. Then I will move my 0 point, the point that's usually at the origin, to the right pi units, which puts it here at pi. And so if I shift that, we should hit 1 exactly halfway between pi and 2 pi. This is 3 pi over 2. And so we should hit 1 there. And we should hit -1 exactly between 2 pi and 3 pi, which is 5 pi over 2. So we should hit -1 there. And so our sine function didn't quite hit the point there, guys. We'll move that. And that's 5 pi over 2. And so that is our sine function shifted to the right pi units with a phase shift of pi units. And see how it is just the purple graph shifted to the right pi. All right, let's look at cosine now. And for cosine, again, we're going to identify A, B, C, and D. Our A value is 1 because there's no multiplier in front of the cosine. Our B value is 1 because there's no multiplier in front of x. Our C value, now because this is a plus sign, right, the minus is part of the formula, that's a plus sign. That means that C is -pi. C is -pi. And then D is 0 because we don't have anything being added on the end there. Again, here my amplitude is 1. It's the absolute value of 1, which is just 1. And my period is 2 pi over 1, which is 2 pi. And our phase shift, that is, again, C over B. So that's -pi over 1, which is -pi. And what that actually means is that we are moving left pi units. And then D being 0 means that our vertical shift is 0. So the only thing that has changed from the parent function for this particular cosine function is that it moved left pi units. And because we're moving left, we're going to draw some space on the left side of our y-axis. And again, my amplitude is 1, so I just need labels for -1 and 1 for my amplitude on the y-axis. We're going to put labels for -pi and -2 pi. And remember that we have pi over 2 and 3 pi over 2 in between, -pi over 2 and -3 pi over 2 on the left. Now, what does our cosine function usually look like? Our cosine function usually starts at 1 on the y-axis, comes through and crosses the y-axis at pi over 2, hits -1 at pi, crosses the x-axis again at 3 pi over 2, and then hits 1 again at 2 pi. And remember, it's continuous, so we have little arrows. And that is what cosine usually looks like. But our cosine function has been shifted to the left pi units. So we're going to move each of those key points, and our key points are here at x equals 0, y equals 1. Here at x equals pi over 2, y equals 0. Here at x equals pi, y equals -1. Here at x equals 3 pi over 2, y equals 0. And here at 2 pi, 1. We're going to move each of those points left pi units. So I'll start with my x value of 0, which is this y-intercept here at 1. I'm going to move that left pi unit, so I'm going to move it to -pi right there. If I move my x-intercept at pi over 2 left pi units, that comes to -pi over 2 because this distance here is pi. If I move my -1 value at pi, that minimum point left pi units, I'm hitting the y-axis at -1. If I move my second x-intercept, the 3 pi over 2, left pi units, I am going to be here at pi over 2. And if you move the 2 pi point left pi units, you're going to end up at pi. And so here is your graph of cosine shifted left pi units. So guys, the important things to remember here are that your C value changes signs when you pull it out of the parentheses. So it's -pi there, but my C value was +pi. It's +pi here, but my C value was -pi. All right, so C value changes signs when you pull it out of the parentheses, and that your phase shift is going to, its sign is correct. It's going to tell you which direction to move. So this is +pi, which means we moved right, and this is -pi, which means we moved left.